Right, let's do an example. Let's sketch g of x is equal to negative half x squared minus 3 with intercepts and a turning point. Let's examine the standard form of the equation. A is clearly a negative number, so we say it's less than 0, and that means that it's upside down parabola, meaning that the maximum is at 0 minus 3, because minus 3 is your Q value. Let's do step 2. Let's do the intercepts, both x and y. If we're doing the x-intercept, we say that y is equal to 0. So we say 0 is equal to minus a half x squared minus 3. We take our 3 to the other side and we change the sign. We're left with 3 is equal to minus a half x squared. We transfer the negative sign. We then multiply both sides by 2, giving us minus 6 and x squared. Now we know that you can't take the square root of a negative number. Therefore, there is no x-intercept, because there are no real roots. Right, let's move on. Let's do the y-intercept. We say x is equal to 0. And we move forward. So we say g of x is equal to minus a half of 0 squared minus 3. Here we've written x squared, so let's fill in our x is equal to 0. We've got minus a half times 0 squared minus 3. We then say we've got minus 3 for g of 0. So our point would be 0 minus 3. That is our y-intercept, as well as our turning point. Let's do step 3. We know that we've got 0 and minus 3 as our turning point, so we draw our upside down parabola. It's upside down again, just to remind you, because the a value is a negative half. We label our graph as minus half x squared minus 3. We now need to do our domain, range, and axis of symmetry. We agree that the x is an element of all real numbers from negative infinity to positive infinity. However, the range is limited to every number from negative infinity up to and including negative 3. So we can put a square bracket around that. Our axis of symmetry is x equal to 0 because there's no shift to the left or to the right.